Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about Ramsey Cass Koopmans Model. This model is cornerstone of modern macroeconomics. According to Solo Swan model, people save fixed proportion of their income. But according to this model, saving rate is endogenous. That means saving determined within model based on decision of household or a firm. Household are very rational and forward looking. They decide how much they need to consume today or save for tomorrow in order to maximize their lifetime utility. This model also explains long-term economic growth through capital accumulation and determined path of steady state equilibrium where capital and consumption grow at a constant rate. Assumptions. Household are representative agent. They want to maximize their lifetime utility. Inelastic labor supply, that means a household supply exactly one unit of labor regardless of their wages. Use Cobb-Douglas production function, use Inada condition. We will discuss what are these conditions. Exogenous technology, that means technological progress determined by outside the model. Perfect competition. Closed economy, don't talk about international trade. Use intertemporal utility function. What is intertemporal utility function? We will discuss. No government intervention according to this model. What is intertemporal utility function? Intertemporal utility function represent a satisfaction of household which they receive from consumption over an infinite time horizon. That's why here we have limit from 0 to infinity. E to the power rho t. This is mathematical symbol rho. And rho t represent pure rate of time preference. That means how much household prefer present utility over future utility. U represent total lifetime utility. CT represent level of consumption at time t. DT simple represent time period, and this whole UCT represent instantaneous utility function. Instantaneous utility function represent utility at specific time period, means utility at current time period separate from present and past. Now we will see some feature of intertemporal utility function. Instantaneous utility function, part of intertemporal utility function. First order derivative of instantaneous utility function is called marginal utility. This is sign of first order derivative. First order derivative of instantaneous utility function will be called marginal utility. According to this model, marginal utility is greater than 0. That means people always prefer more consumption. Second order derivative of instantaneous utility function is less than 0, or you can say that negative according to this model. This is a sign of second order derivative. Second order derivative of instantaneous utility function is less than 0, or you can say that negative. It shows diminishing marginal utility. That means additional unit of consumption provide less utility than the last. According to this model, instantaneous utility function also satisfy Inada condition. Inada condition ensure well-behaved dynamic equilibrium. What are these Inada conditions? First order derivative of instantaneous utility function called a marginal utility. So this is a marginal utility. According to this model, if consumption approaches to 0, then marginal utility become infinitely high. That means consumer will never choose such kind of consumption path that lead to 0 consumption after certain time period. Second thing, if consumption approaches to infinity, then marginal utility will become 0. That means if consumer continues buying so many things, then after certain time period, is marginal utility become equal to 0. Simply shows law of diminishing marginal utility. Now we will see another condition for businesses for a firm. This model also talks about a firm. Another condition for a firm shows well-behaved production function. This is our production function where output is a function of a capital. First order derivative of output function with respect to K will be called marginal product of capital. If marginal product of capital is more than 0, that means marginal product of capital is increasing. If second order derivative of a production function with respect to K is less than 0, that means marginal product of capital is diminishing. According to this model, we can achieve steady state equilibrium, or you can say the balanced growth path, when capital per unit of effective labor and consumption per unit of effective labor remain constant. This state is found by setting derivative of capital and consumption equal to 0. This is a derivative of consumption, this is derivative of capital, which is equal to 0. We clearly understand this concept with the help of a diagram. Now we'll see diagram. Horizontal side we have capital. If we are moving forward from 1 to 2, 2 to 3, 3 to 4, 4 to 5, that means capital increasing. So this arrow shows capital increasing. But if we are moving backward, 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 3, that means capital reducing. So this arrow shows capital reducing. We are moving backward, but this arrow shows capital increasing because we are moving forward. Vertical side we have consumption. This arrow shows consumption increasing, but this arrow shows consumption reducing. This arrow shows consumption increasing. This shows capital reducing. This arrow shows consumption increasing, capital also increasing. This arrow shows capital increasing but consumption reducing. This arrow shows capital reducing, and this arrow shows consumption also reducing. Similar, this arrow shows consumption increasing, this shows consumption reducing. Similar, this arrow shows capital reducing, but this shows capital increasing, because here we moving forward but here moving backward. This vertical line shows derivative of consumption function with respect to time is equal to 0. If derivative of consumption function with respect to time is equal to 0, that means consumption is constant. So this vertical line shows consumption is a constant. This curve shows the derivative of capital with respect to time is 0. That means this curve shows or capital is a constant. Is equilibrium point, because this equilibrium point shows level of consumption and capital are same, plus this equilibrium also shows level of consumption and capital are constant. So E will be called our equilibrium point. So what does this dotted line shows in this diagram? This dotted line shows saddle path. Saddle path is a unique and stable path which lead economy towards steady state equilibrium. Now we will see criticism. This model ignore wealth distribution. This model also ignore effect of inequality. According to this model, technological progress is exogenous, but Arrow and Romer assume technological progress endogenous, not exogenous. This model assume perfect competition, but there is not always perfect competition. This model based on closed economy, that means ignore international trade, which is very important. According to this model, individual plan their infinity future, but in reality individual face so many problems, so many uncertainty, they cannot plan their infinity future very easily. According to this model, labor supply curve is inelastic, but labor supply not always inelastic, it can change. This model based on Cobb-Douglas production function, but Cobb-Douglas production function failed to hold real world scenario. So this is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.